Okay, and finally, just one last example for distorting grids that I think, again, brings back in some of the stuff from the first exercise and maybe some of the things we talked about in class in terms of how you might, instead of just using a rotation and a radius input that changes according to the location of an attractor point, but you can also apply a movement or controlled movement to those center points of the circles as well. Instead, we'll apply it to a distorted grid, but it might be fun to just kind of follow up and close the loop on that, again, to kind of do an effect that's a bit like this one, or this one. Instead of it being multi-layer, though, we're just going to use one layer just to kind of illustrate the idea. So go ahead and build yourself a grid. All right. Okay, so similar to what we've been doing here, as a way to get started, go ahead and flatten that because I'm going to use another standard attractor point process here, and then instead we're going to kind of feed that into a GraphMapper. So we're going to kind of start combining, our techniques a little all the way throughout what we've covered so far. So I'm just going to pass this through a point object here because I want to see maybe not the grid right now, just the points. Again, just kind of selecting what my previews are and going from there. The next step is to just sort of drop in an attractor point. Okay, this should be getting pretty familiar at this point. Internalize that data. Delete that, doesn't matter. All right, so let's go ahead and use the pull component, the pull point component. All right, so we'll pull the points from the grid over to our attractor as usual. And now you might recall the remapping component. And before I talked in an earlier video, I talked a little bit about how we might use that instead before the GraphMapper instead of after. And this is a good application for that because now we already have a range of numbers here. We don't have to invent those numbers using the range component. We've got our values that we want to start playing with. Okay, so to get started, I'll just go over to parameters and grab that GraphMapper from the input again. And I'm going to go to math. I'm going to figure out what my min and max is, right? I'm going to find my bounds. I need to know that. I also need to know, go over to math and go to remap. And on my screen, at least, it's by default popping up here, but you can go to domain and find the remap. This is going to go into your S input because that's part of that's related to our source data. You do something like that. Keep it nice and neat. And our target we can leave alone at 0 to 1 because again we know that the GraphMapper is going to work by default in that range, and I'm just going to pick, I guess I'll go to the sign for this one. It could be fun to play with. Okay, so we have a set of values that we can already start using here. And remember what we're going to end up moving is the points themselves. I'm just going to move this over here maybe, and I'm going to go to transform and grab a move component once again. These are going to be the points. And then we can use this stuff, to control a movement direction. And we just need to set the direction. So I'll go back over to vector, point, and vector, and we'll grab an X, and we'll grab a Y, and we'll grab a Z. Let's grab all three. All right. And we need to set an amplitude, remember. So we'll go to vector, and amplitude. And the vector that we're going to, in the first case, add an amplitude to is the X. The numeric information that we'll use, the data that we'll use for that, is coming out of the GraphMapper. And we'll go ahead and plug that right in. And we can turn off those original points because now they're just in the way. You can see if we have any effect here. Let's go ahead and make a change to the GraphMapper. We can see that there's a pattern that starts to emerge ever so slightly, right? We start to see a kind of rippling effect here, right? And that's because of the sign movement. Now the effect is subtle, So we can try a couple things. You know, I guess we can move the point a little closer, see if that does anything for us. Maybe. Still pretty subtle, but now we have a kind of an epicenter for the rippling. It's kind of cool. Now, if we really want to make a larger effect, all we got to do is basically just multiply those values coming up. All right. So I actually kind of like when it's out here. I don't necessarily need to see the epicenter at the moment. But what we do need to do probably is just make a little multiplication factor here. So let's go over to math, multiply. And I'll just build out a number slider, I guess, between, I don't know, like 1 and I guess like 30 or something. To give us a bunch of numbers to work with here. So just 1. And we'll use decimal points for this. All right, and that's just going to be multiplier of 1, of course, is the same value, so we could just increase that. We can see that we're really drastically making a pretty big effect now, you know, just by multiplying it a bit on that grid. It's pretty nice. So there's a kind of a move transformation. In addition, potentially, if you go back to the first exercise, if you're interested, you can add something like this to, you know, the little definition that basically changed the circle sizes and their orientation. Another thing we can do is play with the y value, so why don't we go ahead and do that, see what that gives us. So we'll put in, instead of a y vector, see if that gives us, of course that's going to change our pattern a bit, you know, it's going to move things in the y direction instead of the x. Similar. Now if we go in the z direction, let's try that. In this view, we're not going to see anything, are we? Right? Because it's going to be moving in the other view here. So let's go over to perspective. Check that out. And you can see that we've got basically this kind of carpet, sort of magic carpet appearance. You know, the surface now sort of moving around. So this may be another way. Remember, in the last semester, we followed along and we kind of rebuilt that tutorial in order to create an animated version of this for your potentially for your buildings that were floating, right? This is another way to have done that. It's a little simpler. Doesn't really require any expressions, really. We're just using a GraphMapper to kind of control it for us. We could build a new surface through this, and we can show how you do that in just a second. But anyway, just to kind of give you a sense for, you know, producing maybe a different effect here, kind of bringing in a lot of the tools that we've already walked through together. And I'm going to go back to the X for a minute, because one thing I want to do is just kind of show how we might, you know, go ahead and draw our lines back through this. And remember, in I think the second video, we talked a little bit about partitioning. So we'll do that again. And we know we need to partition based on the numbers that basically control the size of the grid. So we know that this value is 35. So let's go ahead and go to set. Let's grab that partition component again, and I'll make an expression on that S input, right? X plus 1. So now we have 36 in there instead. And what we're partitioning is going to be so I'm going to move that over here now. And I guess, you know, again, to keep this script kind of clean, what I'll do is I'll move this in a place where I can see its line. There we go, it's a little better. Alright, so we can keep ourselves organized, and I'll move that all down a little bit. And what we're partitioning in are these points. Then we can start drawing our curves, right? So go to curve, spline, and I guess we just go ahead and interpolate these. You can also try NURBS if you like to see that. Let's turn that off. So here's a set of lines in one direction. You can see the effect that it has, pretty nice. And if we do our flip matrix, we can see the lines in the other direction. So we go to set, tree, and flip. Okay, we'll grab another one of those, and we'll just go ahead and finish off the grid here. And it draws it accordingly. Okay, it's pretty beautiful. And of course, we also have the GraphMapper to give us to, you know, basically control what it is that the attractor point is able to do. You know, we can go a little too far, it gets a little crazy. You know, you want to basically keep it within a realm of, you know, of reason, but it's a really nice kind of quick way to, you know, generate ideas. I think it's a good way to kind of generate some ideas early on in design projects. GraphMappers could be helpful for that. Plus, of course, you have the multiplier, which will make major changes, as you see fit. This will work for all directions, so you can go to Y, and we go back to Z even, and check that out in perspective, and you'll see basically what you might expect to see, which is that surface now, or the appearance of a surface, not a surface, it's actually just curves, but because they're drawn in a grid, you can get a sense that sort of surface-like. And I guess while we're on that topic, why don't we walk through just an example for how we might actually create a surface from this set of points. Alright, so I guess we'll look at these points again instead of the curves, so I'm just going to turn these off for a moment. And this jumps the gun a little bit in terms of our topics, but it's a good time to do it, so we'll go to surface. It's going to be under freeform, and you're going to find surface from points. Alright, so really what we need to know, we just need to know this u value. We just need to know how many points we have in one of the directions here. And we can borrow that again from the same value that we used to do the partitioning. So in Rhino 6 you can do this thing where thought we could just double click and put a relay on that. In any case, let's just go ahead and just use this value again. So what I'll do is I'll drag this component over, I'll plug that in there, and I'll have to make that 36 instead of 35, just like we did before. So x plus 1 as a little expression there. And then we just have to give it the point, so I'll move that back over, and I'll just plug those in there. And now we can see that we have the points, the surface drawn. Right, and there you have it. Leave those points on because we can see the surface a little bit better from them. Or we can even go ahead and just do that because these will be basically mapped to it. Be a nice way to visualize that. Alright, so there's just kind of building out a surface, and this is stuff that we'll certainly get into a little bit later on when we start getting really into surfaces. But there's one last thing I want to show here, as a little bit of maybe a kind of a lead-in to some further topics down the line, which is what we can now extract from this surface. So actually, I'm going to give this a little bit more extreme. Make this a little more extreme, and maybe I'll just move the point in a little just to get moving on this. All right, now in the top view, remember we don't really see much, just a little shade shadow move. But what I'm going to do now, is just to kind of wrap up, is I'm going to take the points that we currently have that's building this surface, I'm going to map them onto the surface so that I can get more information from that surface. So what I can do is figure out what perpendicular direction that I can actually have to draw a curve, or let's say draw a circle from each one of these points. And I can use the surface for this. I can figure out the perpendicular direction off of that surface relative to each one of these points, and I can use that to draw my circle, which will give us that kind of elliptical appearance and plan, which is what we used before, to draw the pattern shift, right? So this time we're using something in 3 dimensions, as opposed to just sort of, pointing the circles toward the control point. I can now use the surface to control the pattern, which might be an interesting alternative. But also, it introduces ways to extract information from surfaces, which will be a pretty big topic as we move forward. So I'm going to go to surface this time, and I'm going to go to analysis, and there's 2 components I need. I need the evaluate surface first, and then I also need the surface closest point. Right, so what I'm going to do is basically pull, in a way, these points to this surface, and the reason is that I want this UV data output. This is the one that we needed. We need this information in order to find the normal vector, which is the perpendicular direction of the surface, right? Because that's what this component requires. If we look at the input here, we can't really use this without this one unless we already have these UV values, which we don't. So I'm going to move that stuff up a little bit. And then we can use the same surface input here. I'm going to turn this off, and I guess I'll turn the surface off. Probably don't need that right now. Now, remember, what I'm seeing here is a bunch of planes that are being drawn. You may be seeing something different, so I'll just remind you that if you go to display, you can change the plane size here. If it's a little bit too big for you, just make a, just change it out, like 0.5 or something, and hit enter, and that will make them a little smaller. In fact, sometimes I just turn this thing off because I don't really need to see it. But if I do want to see the points, I can just use a parameter output here and just plug it into point parameter, And now I can see the points again, which I'll use to draw my circles. And I already have my direction information here. So all we need to do is go over to curve, grab our primitive of the circle CNR, right? Circle center. And there's our center points, and of course our go end to end, basically the normal direction to the normal vector. And we can just set, I'm not going to go through the process of changing out the radii relative to the attractor. I'm just going to take a look at the circles, and I'll shift over now into the top view, and we can see some subtle changing here. And actually what we'll do is we'll increase this quite a bit, basically going a little bit wild with the three-dimensionality of this in order to get more elliptical curves. Again, just to try to illustrate how we might develop this 2D pattern, just to kind of refer back to earlier exercises. But you can see that we're now basically controlling the curves in the circles in this kind of wave-like form using the GraphMapper and using a surface to control the direction of those circles in space. So we have a bit more control over this. We can make it more intense. We can make it more gradual, as we like. And that more or less wraps us up for this one. Let me just turn this off for a moment and just go back here again, because really the kind of goals in this exercise is to talk about from point to line, to really kind of walk through different ways of controlling lines, drawing lines, and in so doing, we are talking about, in some ways, we're really kind of talking about the controlling of organized geometry using the basics of grasshopper data trees, and we talked a little bit about the basics of, Boolean masks that we'll get to in the next set of videos.